So we're here in Estes Park to look at this outcrop, which is very interesting because it's extensively weathered. The rock types in here, there's a few. There's some pegmatite, there's some granite. But what's most interesting is this yellowish color, which is one of the criteria we can use to show how heavily weathered it is. The other characteristic is we can just pick off chunks of rock and break them up into our hand, showing us that the rocks are very weak. So let's think about the chemical weathering process. Usually surface waters interact with the minerals of the rock to produce clay minerals and dissolved ions. So the rocks of the minerals within the rock become different minerals and become dissolved ions. In the case of feldspar weathers to dissolve, say, potassium and calcium and sodium, and clay minerals like kaolinite. Kaolinite's a very weak mineral, and so when a feldspar is breaking down to kaolinite, it becomes much weaker, and we can break it up in our hands as a result. There's still a lot of feldspar. Only some of this has been broken down to clay minerals, but enough that we can then break up the rock as we see here. The dissolved ions, most notably iron, we can see the evidence for. And so the groundwater is carrying that iron dissolved in it, and it precipitates out into what we call iron staining, which is iron hydroxide minerals that will coat fracture surfaces, and that has a rusty color because that's essentially what rust is, and that gives this outcrop this yellowish color. So that's focusing on chemical weathering, but there's also physical weathering going on here, where rocks are mechanically broken up. In Estes Park, in the wintertime, it drops below freezing, so any water within these cracks that we see in the rock will freeze, and that water, when it freezes, expands a little bit, so it can slowly wedge open rocks, cracks in rocks over time. But we also see this tree growing here. And so biology can be a force for physical weathering as well, because its roots are going to grow down into the cracks in the rock, and those roots are going to grow and then again, slowly over time, wedge open those cracks. And so this outcrop is a good place to look at the source of clastic sediments. Of course, clastic sediments are coming from any rocks anywhere that are weathering, but these are the first steps in forming clastic sediments, and then these broken down rocks will get carried to streams, and the streams carry those clastic sediments eventually out to the ocean, where they can be deposited to form clastic sedimentary rocks.